What made Galton's experiment so successful in demonstrating that sometimes simple averaging works? There are three key factors determining what that sometimes might be. One is the definition of the task. In Galton's example, there is a correct answer to speak of. There is an objective answer, that is the actual weight of the ox. In many of what we are looking at, however, there is no objective answer. It's very hard to say, here's the ground truth. The correct average rating should be this, and simple averaging doesn't achieve that. We don't have a systematic way to argue that in that way. The second is unbiased and independent estimates. Both are very important. First, unbiased. Everybody get a good view of the ox. Okay, there is no glass door between them to give a distorted visual. And everybody put in their number into the bin independent of the others. They each write down a number, 1, 2, 8, 9, 9, 4, 3, and so on. And then they put them into the bin without looking at the others. And this is very important indeed. In about 2 lectures time, we'll look at a scenario where dependency of action will break the wisdom of a crowd and turn it into an information cascade. The third one is that there's enough people participating. Now, 787 apparently was a big enough review population. If there were only 2 people, probably it wouldn't work. So somewhere between 2 and 787, for this particular task, under unbiased and independent estimate, it worked quite well, the simple averaging. Now back to our Amazon simple averaging number. Okay, 4.5 star, 3.8 star. How can we better turn into that vector of review into a scalar? Other than averaging, are there better approaches? There are quite a few potential intellectual disciplines that can help. One is natural language processing. If the rating associated with 5 star is a review with a lot of superlatives and very emotional terms, okay, or the text associated with a rating of 1 star is very emotional and clearly charged with a lot of biases, then maybe we can discount those. Statistics. It's often believed that only those who really care about this product and service would enter review on Amazon. Okay. So naturally, there will be a distribution of people who are very negative about something. Then they say, I ought to enter this on Amazon. And there are people who are so happy with it, they ought to enter it on Amazon. So sometimes the product itself has a bimodal distribution. Okay, some people like it, some people don't like it. But independent of that, there's also a bimodal distribution in the sampling of the overall population. Most people who are in between just don't care enough, either positively or negatively, to enter reviews. So by understanding the underlying statistics, we can maybe better process this averaging. The third one is signal processing of various kinds. We can say that maybe we will look at the timing of these reviews. We'll look at how recent is it. Is it a batch processing phenomena like what we briefly mentioned in the last lecture on Netflix? And we will later look at a specific signal processing method called Bayesian estimation. And maybe voting. Maybe we should ask them, instead of just aggregating into a scalar like this, we should say, why don't you, each of you, rank, each person rank all the products, for example, all the LCD HD TV out there, and then I'll aggregate the list from Alice, from Bob, from Chris, and so on, and then generate a ranking order in that way, instead of condensing a vector of review per product into a scalar and then rank the scalar. I asked each individual to give me a complete ranking of the competing products, and then I'll aggregate these rank order lists. This would be a very different approach, is impractical for Amazon because very few people will be in the position or in the mood to do a complete ranking according to some scale of all the competing products. But in other scenarios, such as voting, like what we'll encounter in the next lecture, this will be useful. So before proceeding further, let's take a look at a couple of quick examples. One example, this is from a certain 2011 day. We picked two TVs, LCD HD TVs, one from Philips, one from Panasonic. Okay. This one from Philips got 4-star out of 121 review. This is a simple arithmetic mean, simple averaging. The Panasonic one got almost 4.5 stars, but out of only 54 reviews. So between 4-star and 121 review versus 4.5 star out of 54 reviews, which one would you buy? How much do you trust this 4 or 4.5 star depending on the number of reviews? How do we quantify that intuition? And more generally, if we could generate a whole histogram, okay, of 1, 2, 3, 4, 5 stars and look at a bar chart, would the spread of the stars also make a difference? The average might be the same, but this will look very different from no 2, 3, 4 star, but only 1 and 5 stars. On the one hand, this kind of histogram will alert you because it's a very bipolar opinion on the product or service. On the other hand, you may say, you know what, I'm among those who hold this belief, and therefore this suits me very well. A second example, this is again in 2011, particular month. Look at an iPod Touch review. One chart records the most helpful reviews. So we look at the review of reviews, number of people who found that useful, or the percentage of people who found that useful, and we only pick out those that are believed to be very useful reviews and record their associated numerical ratings. On the other hand, we have a chart that just records the most recent ones. And you can see a clear difference between the two. Now maybe there is a generational upgrade past a certain point in time. This is time, and therefore we won't detect when that happened by looking at, say, the average scores. And more generally speaking, we may say that a rating or ranking based on rating is not a static object. We have to look at the entire time series. You can take a whole course on time series analysis, for example. Now let's say there are 3 different behaviors in this cartoon, A, B, C, where the time axis is on the time scale of, say, month. If this time scale of minutes, actually, it doesn't quite matter what's the fluctuation. But let's say this is on the scale of month, and this is the review that you receive aggregated over each week, for example. This pattern is clearly cyclic, and you may say, gee, this product, is not receiving a stabilized review. This one seems to be stabilizing around a pretty good number, a little above 4, and this one, it's hard to tell. Has it stabilized yet? Can I trust the average over a certain moving window of a certain duration, say the past most recent 3 months, or not? It's actually hard to tell. So now we have raised so many questions, starting from can we trust simple averaging to all kinds of statistical, signal processing, natural language processing kind of questions on how to enhance our ability to understand turning a vector into a scalar and then ranking based on that. Now, we don't have as many answers, unfortunately. Most of the questions we just raised do not have very stable answers in the context of Amazon. That's why it is still an art to decide when should you trust the average rating, or when can you trust the ranking based on average rating provided by Amazon. We'll come back to this in an example very soon. So what we're going to do now is to look at two cases where we do have a pretty good answer. One is averaging a crowd and look at the wisdom of crowd. The other is to look at a Bayesian estimation and adjusting the ranking based in part on the number of ratings